Hi, my name is Donna Malagary. I'm a program manager on the Azure mobile team. Today I want to talk to you about Azure App Service, and in particular, how you can use it to build out enterprise mobile apps with data sync. And I'll talk about some patterns that will be useful as you're building out your enterprise apps. Let's look at the Azure overview. I'll specifically be talking about the mobile features of App Service and notification hubs. Overall, App Service mobile apps have a number of backend and client features to help you build a great mobile app. And you can connect to a variety of data sources. You can do authentication either through social providers or Azure Active Directory, push notifications, and make your app work on a lot of devices with our native and cross-platform client SDKs. Today, I'll be focusing on the offline sync feature of mobile apps and how you can build out a great experience for enterprise-grade apps using the offline sync feature. If you've ever used a smartphone, you know that to have a great mobile app, it needs to be able to handle network interruptions. This can range from someone steps into an elevator and you don't want the app to completely crash, or you have someone with a job where they're out in the field, could be a rural area where someone is working on an oil rig, or could be someone who is just going into a shielded area without any network access. And if you think about consumer apps, most people expect these apps work offline, even though they're not generally using them for real work. When it comes to enterprise-grade apps and employee apps in particular, it's really critical that apps work offline so that people can be productive even when they don't have a network connection. Now, the problem is that a lot of apps, even consumer apps, don't work offline, and it's because it's a really hard problem to solve. It's one thing to be able to cache the data on the device, but when you're offline, that means that people are making changes and not syncing back to the back end right away. So that means that there's a possibility for conflicts, there's a possibility for people making edits that don't make sense together. And these are the problems that we solve for you with Azure App Service. We make all of these things easy, and we offer many client SDKs to help you out. There are a lot of reasons that you should consider this kind of feature for an enterprise app. The most basic reason is just that the app can become more responsive. Instead of loading all the data on demand, basically you want to cache it on the device so when the app starts, it's immediately shows some data and users can start interacting with it. But that's kind of the most basic level of doing offline sync. The next kind of level over is that you might end up having some intermittent network outages. Now, this could be the elevator scenario, as I said, or maybe the app is being used while in transit. So you want to continue to let users interact with the app and be productive. Now, where it gets really interesting is when users can create and modify data even when they don't have a network connection. And what this means is that they're making changes against a copy of the data that might be out of date. And when they go back online to sync their changes, there can be conflicts. And this is something that Azure Mobile makes a lot easier for you as a developer to do. So let me get into the specifics of how this works. In the middle of this diagram here, we have your Azure Mobile backend that runs on App Service. And in the past, we only had basically two easy options for your backend data source, and that was a SQL database or an on-premise data source. Now we have a whole host of other options. You can use Salesforce, you can use Dynamic CRM, you can use table storage, and of course, on-premise data services. It could be SQL databases on-premise, and you can use your own connectors to customize exactly what you're connecting to. What your client app does is it doesn't connect to your backend service, your data service directly. So your client isn't connecting to, say, Salesforce or Dynamics or to your SQL database. Instead, it goes through the app service backend, and that's the abstraction layer that your backend is able to provide for the clients. What that means is that now your client apps can be a lot simpler. They don't have to worry about the complexities of the data model that they have underneath. You can switch out the data backend without the client app even noticing. Basically, it'll just keep working because it cares about the data model that you've exposed. And usually you use a mapping between a data transfer object and the actual object that's in the database to do this. The client will then do some sync calls. It'll do push the changes that it's been making while offline, and it'll pull down new changes to queries. The way the push works is that while the app is offline, the mobile services client SDK records all the changes that have been made. So this could be inserts, updates, deletes. And then when the sync operation happens, it plays them back in order. So the order of operations is maintained. I mentioned conflict handling is a hard part of getting offline sync to work. And what Azure Mobile provides you is conflict resolution either on the client or on the backend. So maybe you want to do backend conflict handling because you don't want the end user of the app to ever think about conflict handling. You don't want them to have to make a decision. And maybe there's business rules that you can apply in the backend and just make the conflicts go away. Alternatively, maybe you want the conflict handling to be on the client because you want the end user to decide what version of the data to keep. And so with Azure Mobile, you can do conflict handling in either place or even both if that's what you choose to do. So with all that overview of offline sync, let's get into the first pattern. Oftentimes, when you have structured data in a database or in a CRM system, you have files that are related to this data. And it's a common pattern to sync these files either on demand as part of those records or later on as the user wants to see them. Depending on the size of the file, maybe you want the user action to determine whether or not the file is brought down. So to give you a customer example of where you would have associated files, there's the fault reporting app for Transport for London. And Transport for London manages all of the various transport systems, as its name says, for the City of London. So you can imagine there's a lot of things going on. And with a city of that size and that's that busy, they needed a way to let employees of Transport for London report issues and have them go up to a central database. And you don't really want to be carrying around a bulky laptop to do fault reporting. So they have this great innovative mobile app that allows this fault reporting to happen. It's secure. The authentication happens through Azure Active Directory. And employees can record data and images that go along with this fault. So that's the associated file pattern of offline sync. So another example of where you would have files that are associated with your app data is another app that's doing a similar kind of thing with hazard reporting for a large mining company. Except in this case, their backing data source is Dynamic CRM. And it's a similar kind of situation where they're reporting fault and they have associated images that go along with the records that are in the database. The way that you would code this up with Azure Mobile is to use our new file sync APIs, which is a client feature, or client SDK, and our backend service. So essentially, in your app service backend, you have a connection to the connection string for your storage account. And the client device does not have any direct connection to blob storage. So you're not distributing your master key with your client device. You're keeping that safely in the app service backend. So when the client wants to upload an image, for example, it will request from the backend a storage token. The app service backend has this master key stored. So it's secure because you're storing it in the Azure data center rather than distributing it to all the clients. And you can decide what kind of policy for a shared access token to give back to the client. Essentially, that's how in blob storage, the token storage access is granted to clients for individual files or containers. And it's completely under the developer's control how to customize what's sent back to the client. Basically, what's the timeout period of the SAS token? Maybe it's just 5 minutes, maybe it's an hour, and how that record is actually going to map to a location in Azure Blob Storage. Maybe you have a particular naming system you want to use, and we make that all really easy to customize. Now the backend will send back a storage access key to the client device. And the client device can now go directly to blob storage. It doesn't have to go to the app service backend anymore because now it has the key and it can do this on its own. And this is really important for scalability. With blob storage, you can geo-replicate your storage and have it available in multiple locations. And you don't want to set up a particular backend as a bottleneck. So it's really important that this architecture allows the client to go right to blob storage directly and upload the file in the right location. At the same time, you have full flexibility over where the client puts this data and what kind of permissions it has. So let's see a demo of this in action. Here I'll be using a field engineer demo where a field engineer can see all the jobs that he or she has upcoming and take images and supporting documentation, and they don't need to be online while doing this. So here is an app that you would see. In this case, it's a cable repair person. And so they have a few jobs here. The jobs are all, the customers for these jobs are all members of my team, including myself. You can see that I ensured that my job is completed, but my coworkers' jobs are still active. So for this particular job, for instance, this is a customer. Here's my manager. The technician gets on site and sees the TV is completely broken, and that's the associated image here. And perhaps the technician repairs everything, maybe glues back the TV together, and can take a photo. I don't have a camera attached because I'm using the iOS simulator. So what I'm going to do here when I add a job photo is just to choose something from the camera roll. In this case, it's this beautiful architecture. In the case of an actual app running on a real device, they would take a photo of the repair, and then they could mark the job as complete. Now, when you go back to this UI, you can see that the status changed, but there's still a pending sync change. So essentially, this app is behaving as though it's always offline. And if another engineer were to look at this job, or someone in the back office were to look at this job, it would appear as though it wasn't complete until this particular app will sync again. And now for a real app, you probably would want to sync on an interval or do some other ways of doing sync that I'll get to later on. So now the changes are synced. That means the change has gone through to the back end. This app is written in Xamarin, uses Xamarin Forms. And let me just show you a little bit about the code that is doing this file access. Essentially, it's adding a file to a record is as simple as associating the file with the particular record ID that you have. So here, for instance, there's a job, and you create a file that's associated with that job. And the SDK takes care of all of the work of doing the file upload itself and getting the permissions to do the upload and all that kind of thing. Similarly, when you download the file, there are helpers that will get the file path for the particular job that you're on and download it. And this example has an additional feature where it doesn't always download all the files. For the files that have to do with the images that the engineer took, it does download them aggressively every time it syncs. But there's also an additional property, which is the service contract, which is a PDF that is associated with the record. This particular one doesn't. So this would be the terms of service that the customer has with the cable company. The next pattern that I want to talk about is per user data. Actually, the example I just showed you does use per user data. If you noticed, I had all the jobs for the given cable repair person, but not anything that company is working on at the moment. And there are a lot of reasons to filter out the data. One is you just don't want to keep all that data on the device. You want to keep the UI looking nice and simple and focused to what the person using the app wants to actually do. The other reason is could be for permissions. You only want to let somebody make edits to jobs that they actually own so that they don't cause problems for other people. The way that you can do that with Azure Mobile is to do some filtering you can do the filtering even either on the client or on the back end. Let me show you an example that uses Dynamics CRM that does filtering on the back end. So what I have is a client app that connects to Dynamics CRM online with a connector that we have available, and the sample app is also available to customers. And once I run this app, you'll see that it's going to show me the customers that are owned by me in Dynamics CRM. So essentially, it's not showing me every single customer that's in CRM, but just those that I own. And what I can do is do a check-in task and write some notes on what happened when I just had a conversation with a particular customer. Now, the same thing is happening here. This app is working offline. You can see that I have one item to sync because, again, this pattern this app is showing syncing by user action. And once I sync, if I were to go back into Dynamic CRM online, I would see that it was my personal user that made an action against this database. So it keeps the fact that I'd made the edit and not just some kind of service admin, which is important because when you're making these kinds of edits to a shared database, you want to make sure that you know who's actually making all these changes. Now, the way that this app works is that it is filtering the data that's returned on the server. And there are two reasons to do this. One is that if you always are filtering data based on some criteria, it's just more efficient to put it on the server side because if you have multiple client implementations, you can make sure everything is working the same way. The other reason is that there could be security permissions involved. And so you want to make sure that you can't have a rogue client or someone decompiling a client that can get access to records they really shouldn't. So an example of what this query would look like on the server, here we have the field engineer query that I had showed before. And what it's doing is it's filtering only jobs that are equal to the logged in user. For the Dynamic CRM case, it's a slightly more complex query because it's querying against the Dynamic CRM system. So the query is constructed slightly differently, but you can see it's doing the same thing. It's pulling down activities or contacts that belong to the logged in user. And this filtering doesn't have to be just on the main entity. The CRM app does the same kind of filtering when it comes to each child entity. Just as long as you can do a query that will look up the owner, you can do this kind of filtering on the server. And what this means is that there's less data stored on the device, and you're ensuring that your permissions are honored on the mobile device as well. The next pattern is push to sync. And essentially, this is trying to solve the problem of client devices, and they need to know about changes to the backend data, but you don't want them constantly pulling and checking for changes because that can, have an impact on battery life. It can increase the amount of data that's used on the client because it's just opening connections, and most of the time it won't have any changes. And it's also adding load to the server because the server has to continually check to see if there are changes. So what push to sync does is it allows the client to just sit around and not sync very often. Maybe it will sync once every hour or something like that, or when the user actually asks to sync. And instead, the server is going to send a push notification to the client when the client needs to wake up and do a sync. And the client will basically say, this is the query I want to be notified on. The server will register that and will send out the push notification. The push notification doesn't need to contain all the data that needs to be saved. All it has to have is an ID of what the query is. The client will then get the push notification. This could even be with a background task. The app doesn't even have to be running. The client will wake up, get the push notification, and sync that particular query that's changed. Essentially, the way you would implement this is map the client query to a tag in notification hubs. And I'll explain how that works. But then the server is going to use those tags to send the query back to the client. If the data is changing very infrequently, there are two ways to implement this. Basically, if it's infrequent changes, you can have the server send the push notification right when the change occurs. And you could also do a scheduled job to check for changes for registered queries. If your data is changing a lot, you really want to use that second option, where on some interval, let's say every 30 minutes, every hour, maybe less, you have a scheduled task that's looking for these queries that clients have registered for, looking for changes to these, and if there are changes, sending a push notification. What this means is that if there are clients whose queries never change, then they don't even have to bother the server with the query, and you have those savings on battery life and data usage that I mentioned. And the way that this all works is using a feature of Azure Notification Hubs called tags. Essentially, a tag represents a user and a set of devices. So if the same user is logged into multiple devices, they're going to send the device ID along with the tag that they're registering for to the notification hub. And the notification hub takes care of all of the nitty-gritty details of how to actually send out that push notification. Because what notification hubs needs to do is go directly to the platform notification services like Apple's or the Windows notification service or Google or what have you, and it's handling all this load for you. So the code that you write on the client is much simpler. Basically, you'll get a handle for your push notification service. You'll pass along that tag that matches the query that you care about. And the backend will use notification hubs to send out push notifications for those queries that have changed. And then the clients will then wake up and do the sync, as I mentioned. Now, this can have a lot of implications for scale. So you need to make sure that you don't increase the load on the data source more than what the server can handle. So the queries need to be designed so that the server can do index columns to figure out if something has changed. You want to also minimize the number of queries that are specific to a given client. So if everyone is using reference data, for example, then the server, when it's checking for changes, it just has one query to see if anything has changed. Now, if each client instead has their own specific query, then when you run this scheduled task, there's more load on the database. So this needs to be managed with the frequency that you're using to send out these updates and what kinds of queries you want to run. And so, of course, if the load is very high, you need to consider ways to mitigate the load on the database, like sharding the database. Maybe you could use a secondary database for your change queries and that kind of thing. This is a really common pattern, and if you're using Exchange, you're already seeing the implementation of that. Exchange is using notification hubs and to send out push notifications to clients who then need to go and get new email for those folders that the client has set up to sync. The fourth pattern is reference data. A lot of times there are apps that have data that's not changed very frequently, but it's shared among a lot of clients, and you need it on the device because you don't want to be loading all this data on demand. You want to make sure it's around, and you want to ensure that the rest of your app can integrate with this reference data in a really rich way. An example of this kind of reference data is the same mining company also has an app that has all of the rail rule guidelines. And this is an example that uses both reference data and files that are associated with data. And essentially, instead of engineers carrying around a big binder that has all of the safety procedures that they need to follow, they have this reference data in a mobile app, and there are associated PDFs that go along with this. The reason that it's interesting to use mobile services to do this kind of reference data is that in addition to doing the syncs, this is just a regular SQLite data store on the client. So you can write code that queries against it directly. Basically, when you set up the store, you can save a handle to it, and you can issue your own custom SQL logic via the read async method. So this means that you can use the offline sync feature not just for data that you're going to store into your backend system and the operation queue of all these writes that are saved out, but you can use the full power of SQLite to run more advanced queries against your local store. If you want to learn more about app service in general or offline sync, these are a number of links. The Field Engineer app that I've shown is open source and is available on GitHub, as well as the Dynamics connector that I've shown. Thanks a lot for listening to this talk, and enjoy using the offline sync feature of Azure Mobile.